meeting after 1.5 years. My surname is a bit tough, Çetecioğlu. So my whole name is Zeynep Çetecioğlu, and the Gurol is coming from my husband. Today I will talk about the more engineering approach after the Thomas and Robert, because they talk about the nature-based solutions, how we can develop wetlands and how we can treat the water and increase the water quality. But still there's a phosphorus in the sediment and also a bit water column, and it's deposited there. So how we can solve this? So the project what I lead at KTH is the phosphorus mining from the Baltic Sea sediments by using the bioengineering approach. This is the current situation. Sorry, I only show the really the worst pictures, but one of the main problems in the Baltic Sea is eutrophication, because there are the really high load of the nitrogen and phosphorus for the many years, and it causes the oxygen depletion, limited fishing activities, loss of biodiversity, and also algal blooms. And it affects the Baltic Sea in terms of the economical or social activities and ecological life. Of course, this is not a new problem. There are the many countries around the Baltic Sea, and during the many years, they were discharged to the Baltic Sea in terms of the wastewater and also the runoff stormwaters from the agricultural area. So you could see the nitrogen and phosphorus amount for each year, how it increased till the 1990s. These two parameters, nitrogen and phosphorus, the reason of the eutrophication. And then the governments realized how it's going worse, so they try to control it and start to decrease this discharge. However, nitrogen can be removed by the microbial activities in the sediment by mineralize the all nitrogen pollutions to the nitrogen gas, but phosphorus cannot. Phosphorus is phosphorus. Stuck in the sediment, it can be in the microorganism's body or it can be in the sediment, but still there. So how we can solve this problem? We can change disadvantage to the advantage maybe. So this is the project subject, and we try to recover the phosphorus in the sediment. It is important also for Europe, not only for the Baltic Sea countries, because phosphorus is the critical raw materials for Europe. And most of the phosphate rocks are from the north of Africa, Morocco. So we don't have any source in Europe to use, but phosphorus is a key element for many industries. Also, you could see that here United Nations Sustainable Development Goals, and if we can achieve what we want to do, we will provide some of them. And also our aim really parallel of what EU wants, so we can supply this source. It works with the Green Deal and the zero pollution subjects. This is our project name, when we started last year. Ece, maybe most of you already met with her. She's also in this room. She's working in this project since September 2020, and our project is funded by the UTO Initiative, Zeynep Family Foundation, and Baltic Deepwater Torch. What is our aim? We want to use native microorganisms if we can. So what does it mean? There are already microorganisms in the sediment, and they accumulate the phosphorus, and they release the phosphorus in the different time of the year. So if we can exploit their capacity, we can use this capacity for the reactor treatment. We know this information from the wastewater treatment plants, because when I show you how they decreased the nitrogen and phosphorus discharge to the Baltic Sea, because the engineers developed treatment technologies. This is the reason. We didn't stop to use the phosphorus. We still continue to use. So if we adapt this technology to the Baltic Sea sediments, we could recover the phosphorus, hopefully. So this is the idea. And the aim, of course, overarching aim, to propose a sustainable solution for the Baltic Sea and promote the phosphorus recovery. And how we will do this? We try to, now still we're in the optimization step, try to optimize the microorganisms and the reactor operation in the batch scale, and also we will try to precipitate the phosphorus to have a market-ready product if we can. And also we have a parallel study, pilot study. To achieve this, we still need the carbon source because Baltic Sea is not rich by the carbon. So we are trying to produce the carbon from the municipal waste streams as well. Okay, the dream is big, the reality is very small. 50 milliliter bottles, you can see there. These are small batch reactors because we need to set up really more than the 500, close to the 1,000 bottles to see how it's changed. And now we are already completing or almost completing this step. And before these batch reactors, we characterize the sediment and the water samples. And we will start long-term continuous reactor operation in the lab. And hopefully, we will design and set up a pilot plant here in next year or maybe in 2 years. Depends on the results, how it's going on. Our first samples were from the Bagenfjärden and Farstaviken. Sorry for my bad pronunciation. We took the samples last year, October. And we characterize for both sediment water and pore water. And actually, the main challenge for our proposed system, this is a big pollution for the marine environment, but really diluted for the reactor operation. So we have to optimize our system with very diluted water and the sediment. So the phosphate in the sediment in the water, you can see here in the Farstaviken it's a bit higher. Maybe I can show by, no, you cannot see. And in the sediments, it's also Farstaviken is much higher. But when we come to the organic phosphorus and the inorganic, Bagenfjärden is much better. In our parallel study, we use the different waste streams to try to find out the best carbon sources to feed our reactors. So we use the food waste and primary sludge from the Henriksdal wastewater treatment plant, and also we took the samples from the bakeries production industry, vinasse, because it is really suitable to produce the VFA. And also we use the Baltic Sea microorganisms, the sediment, and also already engineered design system microorganisms. And we achieved to produce more than the 75 acetic acid in the whole VFAs by using the municipal waste streams. So most probably we will continue to feed our reactors with them. I couldn't show all results, but these are first set, let's say. So what we have done in the first set, we set up everything in a 20 centigrade degree. It was already the room temperature in the lab. We started with the anaerobic part because our first aim to release the phosphorus from sediment to the water column, and it happens with the anaerobic conditions. And we use the VFA mixture from 1,000 to 10,000 milligram per liter. And this is the first result. So you could see that in the first weekend, we reached the highest phosphorus release in the 1,000 milligram per liter VFA rich feed conditions. But when we come to the Bagenfjärden, we have the much higher phosphorus release, but it was with the 10,000 milligram per liter VFA feeding, and it is not good because when we test after all the experiments, still the VFAs, very much VFAs are in the reactor. So we decided to change the focus, try to optimize these conditions with the 1,000 milligram per liter VFA, but test the higher temperature in the reactors and by mixing and without mixing. And also, as you can see here, that we received the highest phosphorus release in the last day. So maybe if we continue to operate the system, it can be higher. But it doesn't, unfortunately. But it could be the reason we wanted to use the same sediment, and the sediment was in the fridge for more than 8 months. So most probably it affects the activity as well. But these results still show many things relatively because we don't need to mix. We don't need to heat the reactors. Still, we can get the highest release in the 20 centigrade degree. and the same pH 7, neutral conditions. It is also good. We can operate the reactor more environmental friendly. We don't need to feed any acid or base. This is the Bagensfjärden, and the results is more or less the similar, but less phosphorus release than the first set. Also, before to come to the future research, we did the other studies as well. We used some chemical approach, we decreased the pH, and we released all the phosphorus, so we can do this. But it is not very environmental friendly and easily to handleable. And also, Ece was in the Vienna last summer to test the wetlands, floatable wetlands. So somehow there are the boats and all the, that the plants on top of this, and we can remove more than the 90% of the nitrogen and more than the 50% of the phosphorus by these boats. So we don't want to use directly those in the first step, but definitely we will need a pollution step after the reactor operation. So it's also good. And for the future research, we will continue bioreactor operations, and we will test the bioleaching and the bioaugmentation. And we also need to test the toxicity if we can put back the sediment to the reactors, the marine again. Thank you very much.
Thank you, Zeynep. So next up, we have Fredrik Gröndahl, Center Director for the recently started National Center for Future Seafood, Blue Food. Welcome, Fredrik.
Thank you. Well, my name is Fredrik Gröndahl, and I will tell you a little bit about what I'm doing for my research. And I would start to present here the planet Sea. This is 71% of the Earth. It absorbs 50% of all the carbon dioxide that is released by human beings. And every second breath you take comes from the sea. So this one, we should be very careful with it. And that is the reason we have to unlock the big potential of the sea. So if we want to have a sustainable future and be 10 billion people here in a couple of years, we have to see how we in a sustainable way could utilize resources from the sea. We could put out energy systems there, wave energy, wind energy. We could promote aquaculture, cultivation of algae, mussels, etc. And all these things are called blue growth. And now it's the United Nations decade of sustainable science for the sea. And therefore it's a good opportunity now to focus on the sea for the coming 10 years. I will tell you a little bit what we are doing in many different projects that we are running at KTH. And this is what we have been doing both in Trelleborg in Skåne, but also on the island of Gotland, where we are collecting beach cast or beach wrack from the beaches. And we are also mining for phosphorus, but we are using the algae here that have collected the phosphorus, the nitrogen from the sea. And this is not new. This is something that was done on the island of Gotland and in many other coastal areas in Sweden. These are more than 100 years old picture showing how they are taking up the beach cast and they put it on the agricultural land, recovering nutrients that have been from the sea. And this was a very valuable resource. But then we started with industrial fertilizers, the one from Morocco that we just learned about. And of course, a lot of these have leaked back to the Baltic Sea, for example. So now we are running a project where we are recovering the algae and use them and see how this works in a more scientific way on different crops on the agricultural land. And this is my PhD student, Hanna, that unfortunately wasn't here today working with this project. And the nice thing is that the vegetables and crops that we cultivate in the seaweed is getting also more nutritional value than the traditional fertilizers that we use. So we get more nutritious food also by doing this. I will now take you into another project that we've been working with for many years, and that is to utilize the forests of the sea. And here you could see brown algae, red algae, green algae. This is from the Swedish west coast. And we are looking into all these algae and see what we could do with them. Now we want to turn our society from a fossil-based society to a bio-based society, and everybody is looking on the forest. But forest will not be enough. If we're going to manage this, we have also to look into the forests of the sea, and algae is one of these big resources. We could do it on the west coast, but we could also, what happens now? But we could also do it here in the Baltic Sea. These are green algae that are very common here in the archipelago, and we are doing cultivation for food of this algae on island of Gotland. It's a very delicious one, and you could eat it, and it's called the truffle of the sea. Very valuable algae. Goes for several thousand crowns a kilo. One big project that had been developed during 5 years of our research is to create big farms where we cultivate kelp, big brown algae, in the archipelago of the Swedish west coast. And that project was called Sea Farm and was located at KTH. From this Sea Farm project now we have a spin-off company called Nordic Sea Farm that have got permits of 30 hectares now of sea area to cultivate seaweeds for a lot of different things. What we do in the Sea Farm and the Nordic Sea Farm is to cultivate this kelp on ropes in the water. This is about on 1-2 meter depth. We deploy them into the sea. They are 2-3 millimeter in size, and after 5 months they are 3 meter, and we harvest them. Nothing grows that fast as these brown algae, and we don't have to fertilize them. We don't have to irrigate them, and they don't dry out, of course. So there are big advantages to be a farmer at the sea, in the sea. This is just to show a little bit of our harvest and how it looks on the rope. This is sugar kelp, and we could use it for many different things. We are working with something called biorefineries, where you could develop pharmaceuticals, food, fine chemicals, feed, and bio-based material or energy, alcohol, biogas, etc. And you could do everything with algae. It's actually a super thing. There's so much you could do with the algae, and it must be a part of the sustainable future and will be a part of the sustainable future. This is just showing you some of the things we are working with, doing experiments. This is like insulation for houses where we use beach wrack. We do construction materials like bricks, mixing algae and sand, and also incorporating algae in concrete in order to make it a little bit less emitting of carbon dioxide. Here you could see the choice of food for the future, and you could make your own choice. You want to eat insects to get the protein, you could do that, but you could also go in for the algae, and these are algae from South Korea, where people have been eating algae for a very long time. And me personally, I think this is more delicious, but I'm biased. Anyway, the Nordic Sea Farm company that just now starting and developing very rapidly. Here are products that are already on the market coming from our research at KTH, like vegetarian sausages and vegetarian seaweed burgers. We have a very delicious gin and now also a beer on the market. And we are doing, together with the polymer chemists at KTH, doing plastic materials, but that are not that dangerous, that traditional plastic. We do it with the alginate, and you could actually eat these disposable cups when you have used them. It's nothing problematic with them, with the microplastics, etc. So this is already on the market, and this is developing very rapid, and we are very open for new innovation. So everyone who wants to use algae could get cultivated algae from Sweden now. This is another little project that have developed, a research project from Formas. And this is, cows. They are releasing, in this case, more carbon dioxide in methane, but that turns into carbon dioxide equivalents, like all these countries together, and that is blurping, what do you say? Yeah, farts from cows. And there is a project now we run with the Swedish Agricultural University and KTH. I'm delivering the algae and doing the life cycle analysis, where we could depress this methane release from cows. And this is a very interesting thing. And we have found several interesting species from the Baltic Sea that have this inhibiting effect. We are working with harvest of reed in the Stockholm archipelago, and this was something you were doing here also, I heard. So we have been doing that, and also on the coast of Småland. We are working with cultivation of mussels, both on the east coast and west coast, so new opportunities for aquaculture. They are very protein rich and very delicious, these mussels. Even from the Baltic Sea, they are an excellent feed for cows, for example. And this is one of the final pictures here, just showing how we merge different technologies at KTH. In this time, the robotic center that was here yesterday, where we are developing a small autonomous underwater vehicles to be an inspector of the coming growing sea farms that will be located out at sea, saving diving and ship time, etc. That is very expensive. Finally, this is a number of projects we are running on this blue growth thematics at KTH there. We are working with multi-use of maritime space, that we combine wind farms together with aquaculture, for example, to optimize the use of the maritime area. We work with biogas. We are looking with we do plastics, we do adhesives, etc. And this is in cooperation with many different research groups at KTH and at the universities. This is my final picture. It's just from the harvest of the Nordic sea farm, showing the big harvest you could get. And we started 2014. No one had tried this before. And now we see that we have very good conditions for this in Swedish water. So this may be a growing industry, or will be a growing industry in the coming years. Thank you very much.
Wonderful. Thank you, Fredrik. So what an inspiration, what an overflow of information. Are you ready for some more? Yes. Wonderful. So next up we have Gunaratna Kuttuva Rajarao from the Department of Industrial Biotechnology at the Royal Institute.
Our conversation always directed towards the climate change. We always, somehow it leads to the climate change. We discuss about these things. And then we always talk about increasing the temperature, the climate, and then global warming, and we always discuss about these things. But the problem is, it's not only limited to the warming of the temperature, the global warming, but it also leads to increase in the precipitation, like the rainfall and the snow and everything. So these are the things also increases. But we talk about the warming up, global warming and so on. And because of this, the future prediction about the climate models indicates that there might be a lot of rainfall erosion, erosivity by 2050. Say, for example, in the middle and the northern part of Europe will be affected, and whereas in the Mediterranean Sea we will have less rainfall erosion. So that is the prediction. But of course, there are a lot of models coming up to understand what will be the future with the rainfall, erosivity, and how much rainfall we will have them. And that will be very much explained if you look into this summertime, that July and August. You heard a lot of news headlines about flash floods and heavy rainfalls and all these things globally, not only in European countries, as you see from Turkey or Uganda or Ethiopia or Malaysia. So there are a lot of things happened in the summertime. And apart from that, it also happened in Europe and around the Baltic Sea regions, right? So we have a lot of rainfall reports and the flash floods in many parts of Sweden as well. So coming to this one, if you look into the Baltic Sea, so the Baltic Sea is surrounded by the huge drainage area in a way, and there are a lot of research is going on, because when you have a lot of drainage, there will be a lot of nutrients and hazardous substances flowing into the Baltic Sea. Of course, a lot of research has been going on for many decades now to reduce the flow of nutrients and hazardous substances inflow into that. So there are a lot of point source pollutions have been identified, and they have been trying to tackle how to solve the situations and make very stringent regulations for the release of the nutrients and hazardous substances into the Baltic Sea. Whereas the flow of stormwater pollutants, which is really like coming up things, like we are really not there yet. So that is still a big challenge, how the stormwater will be flowing and what kind of contaminants they are bringing into the Baltic Sea. Okay, so now I will like to talk about the project which is supported by the Interreg Central Baltic to find out the clean stormwater is an international project, and that will aim to test the stormwater treatment solutions and basically monitor the water quality, so that we can able to see how much nutrients and toxic substances we are releasing into the Baltic Sea. So this is the project, and this project, the project partners are finding pilots, finding a place, catchment area with the water drainage places, and we are also trying to test different technologies in the partner countries, different countries. So the Baltic Sea from Estonia is one of our partner in Tallinn. They are going to construct a pilot site in the Vimsi, and in Finland they are going to construct 2 pilot sites in Avanti and Turku, and in Riga in Latvia they are also going to construct a pilot site. So if I go into the little bit detail what they are doing, so the Vimsi catchment area is like consisting of green areas and gray areas, because if you see the storm water, it comes from different places because the water will be draining. So it depends on what kind of areas, whether you have a parking slot or whether you have an agriculture areas or whether you have forest or like an highways, because you have different pollutants coming from different water transport into the Baltic Sea. So we have to look into what kind of contaminants are there, and then what kind of technology can be used to remove these kind of substances. So we have green areas and gray areas. Of course, then the substances coming from green areas will have a different kind of pollutants, and gray areas will have a different kind of pollutants. And they have a lot of sub-catchment area, because it's more basically like a centralized system for treating the stormwater. So they are trying to use the nature-based solution like a pond system, and they are also having to have a chamber and grid and the underground separator and all these things. And along with that, we are also interested to monitor the water quality, like nearly real-time monitoring. So we are more interested to look at the e-monitoring system, so that we can install the sensors into the inlet and the outlet, so that you can control and have a real effect, like how much nutrients or the toxic substances will be reduced, so that you can control, and you can also test how the treatment technology is working in these ways. Okay? So the same thing with the Finland in Avanti. The pilot site will be located in the developing industrial area, and there the technology is the bioretention basin, and where we have a filter media and the plants will be growing, so that you can, the plants also remove a lot of substances because for their growth and so on. And with the gravel you can remove a lot of suspended solids and everything. So this is the filter bed will be tested, and they are also going to have the real-time monitoring equipment for monitoring the water quality. And in Turku, in another site where it will be located in a heavily trafficked area which has a lot of green spaces around it, and then you will also have the same system to see and compare which kind of pollutants are removed using this technology, and the e-monitoring system will be installed there as well to check the water quality. And in Latvia, so it is in Lukavsala Island. That's where they are going to build. So right now they are looking a little bit empty, but they have been more like a multi-level streets with the infrastructure, and they have a lot of industrial areas and the parking slots. So they have they are going to test different technology like a vertical hydrodynamic vortex separator, which is from the Hydro International company. They are going to bring it from US, and they are going to install it, and they are going to monitor the water quality. So there are different techniques will be tested in different pilot sites from our partners. And from Sweden, we have taken Uto. You heard a lot about Uto Island and the wetland system from Robert and Thomas. So we have taken this site, and many of us visited yesterday to see the wetland system and how it works and so on. So we have selected this island because it's the southern part of Stockholm archipelago, and they have the interesting point is they have a military shooting field and also the old iron mining area. So that is one of the point. Is good to know how the water quality and what kind of substances are releasing into the Baltic Sea. So that is the main interest for us. And they have a very good, constructed a good wetland, and now they are going to build a third wetland system soon close to the military areas. So we are more keen in looking into or monitor how the wetland system works and what kind of. So earlier work what they have done is they have analyzed the sediments of the Baltic Sea with different layers, because they have different sediment depth. So they measured like 0 to 5 centimeter, 5 to 10 centimeters, so on up to 30 centimeter. And they found different substances on different things. So maybe in the top layer you find many substances. When it goes to the deeper layer, you find less substances in a way. So they have different concentrations and different things. But when we look into the water, there were lack of data on these things. So that is why, because water is the one which brings the substances into the Baltic Sea, and they are just like flowing into it, and lot of soluble substances will be there, right? So that's why we are more keen on looking into the water quality and monitor the water quality very carefully over a period of time to understand how the wetland system works in this island. Because as you have been discussing that how the wetland system works and what kind of substances will be removed. So that's why we really need to monitor the water quality. So that is the main idea here. So we are planning to do the sampling points at the different places where the watershed area to the ditches, and the sedimentation pond, and the wetland section, and the Baltic Sea where the water is going out. And they are going to build a third wetland system close to the shooting site by next week. So we are also trying to take the sampling to look into the wetland system, how it works, and what kind of substances will be there, and what is removed, and how much is reduced in this case. And when it comes to the substances, there are certain parameters that can be analyzed, like heavy metals and nutrients, but there are certain substances which are a little bit higher than the limit when they were looking into the sediments. So we were more interested to look into those substances in the water, like to see what kind of substances are there in the soluble form than in the sediments. So this is where we are looking into certain priority substances from the wetland system, especially in the water quality. And we are also more interested to check whether it is possible to have a monitoring system, the e-monitoring system, so that they can have like a sustained way of checking the water quality when they are building new wetland system, and this can be a model for other archipelagos and other places. So that is the main motive for this data collection and looking at the water quality and the wetland treatment plant. So the knowledge from this clean stormwater project, which we are working with the partners, and the implementation from the Maritime Tech Solutions, that's where we are looking for some support. And the real-time monitoring of the stormwater quantity and quality in this Uto and in other project pilot sites, that will benefit the monitoring efficiency and the possible improvement of the Uto wetland systems. So that is our interest to look into that. So with this, and I would like to mention our project partners from Estonia, Vimsi and Taltech, and KTH, and Riga, the Riga City Council, and in Turku University of Applied Sciences. And we also have associated partners from City of Turku and the Leito municipality. So with this, I will thank you for your attention. Thank you.
Thank you, Gunnar. We now have a few moments to ask some questions. Gunnar, I'm going to start with you and talk just what you just mentioned. The need for data collection is huge in this project. It's one of the biggest sort of challenges you have. Can you talk more about that?
Yes. When I say that there are different pollutants, and when we talk about the hazardous substances, when we were looking into the mining places and the shooting spots, maybe there are like polyaromatic hydrocarbons and polychlorinated substances and heavy metals might be there. So we would like to monitor those things. And these substances, it's very difficult to analyze in the lab. So we have to send it to some companies to do this analysis, and they are very expensive. So that's where is the bottleneck, like how many samples you can analyze and what will be the cost and so on. So that is what we are looking for, some support, because the project have very small money to do very few samples. But if you are looking into the wetland systems, 3 wetlands which the UTO is constructing, the UTO initiative, so it would be really nice to monitor the water quality of these substances to see the efficiency of the wetland treatment. As Thomas and Robert pointed out, that this would be like a model for other archipelagos and other wetland constructions. So this will be the data collection, and having this to prove that how the wetland system works will be a great opportunity for future wetland construction systems.
Yeah, but if you implement this data collection, could that be used for other projects as well? Can you use the data for?
Yes, I think this will be a model if it works, and if you show them the efficiency and what kind of substances and when they grow the plants, and because as Robert and Thomas pointed out, that sustainable development, because they are going to grow the plants and they are going to take out to make the earth and all these things. So it's more like a sustainable and growing fishes and so on. So this will be a good opportunity to see the health of the fish and what is the quality, and everything will be matters, right? If you have the data set.
Working with different research projects, I know sometimes it could be hard to see the kind of end game, and and that's part of research, right? We don't know always where we end up. Zeynep, I want to move over to you. When we spoke yesterday, in your project, you said though that you could kind of see the light at the end of the tunnel. What did you mean by that?
I think the problem definition is so clear. And we know that...
Did you put yourself on mute?
All right. Can we hear Zeynep now?
Try. Say something, Zeynep.
can you hear me?
No.
All right.
Because it's still mute, or not?
We can have Fredrik jump in here, talking about sort of concrete applications. I think what you mentioned several very concrete applications. There were gin bottles and burgers and whatnot.
Just go for it. Yeah.
But how do you balance that in your work? I mean, sometimes you go for something that you don't know where it's going to end. Sometimes it's very clear the use case.
I mean, we have been doing for many, many years, and many people involved. So we have done all the basic research, but during these 6-7 years, we have been working with the macro-algae. We have now, we know how to cultivate algae now, so now it's just time to do something with it, and we could start. It gets very concrete, actually.
Right. I actually have a question from the audience to you, Fredrik. It's from Mark in Warsaw, Poland. So nice to see we have Poland with us here today. The question is, how do you combine biofarms with wind farms?
Yeah, that's something that we would like to do. We are working with something called multi-use of maritime space, and since we don't want to have this type of big aquaculture farms all over the place or in the archipelago, because it's a big value also for, you know, boating and pleasure and so on. So, and fishing, etc. So it has to be, when we do this, we have to find areas where we could optimize the use of it. So we could have wave farms on the bottom, wind farms in the air, and in between there we could cultivate mussels or algae. And that is the nice thing with the sea, that you could make many things at the same spot. Much more efficient than land, actually.
Right, right. We also have another question from Boel Niermark. Can you also use the wild-growing Algaes from the Baltic Sea, or only the cultivated species?
Yeah, since the algae, the wild algae, as I showed you, it was like a forest there, and like in the Baltic Sea here, we have bladderwrack, fucus. They are very valuable ecosystem. We don't want to use them when we tear them up, or we could do that. I mean, that is how it has been done for a long time in Brittany or Norway or so. They just take it up. But I mean, that destroys a very important part of the ecosystem. So therefore we say that we have to cultivate them. So we provide new areas for them. We cultivate them on ropes, and they are like hanging gardens there. And we also work with the same population that we have locally, so we don't get any genetical problems. So it's more or less the same, but we provide more space for them, and then we don't destroy the valuable ecosystem.
Right, right. Do we have Zeynep with us now? So Zeynep, going back to the question I said, we're talking about light at the end of the tunnel in a way. So talk about that.
This is very early project right now. So we just started last year, and we are really learning on the way what we have to do. But the problem definition was so clear from the beginning, and we know that how we can end up with which kind of the technologies we can use. But there are many challenges, of course, because there are I couldn't give so much details in the presentation. There are the chemistry background this, and it is working not we are used to in the wastewater treatment plants. There are the many parameters affect the bioprocess and also chemical processes. So we try to solve these limitations or the challenge, but it is pretty much clear the path and what we have to do. But the question, of course, when we come to the end, I think this is always the question for any engineering applications. It will be feasible to go through and to apply in the full scale or not. So, you know, we can do the many things, but in terms of the economical approach, it will be feasible or not. So, but we will see at the end.
And talk about where you are in that stage, because I think, you know, many researchers, it's part of the process to sort of manage the funding of it, and you need funding from different sources, and this is really something we want to talk about here today. Where are you at right now, and what type of funding are you looking for?
We had the starting grant actually from the different sources, as I presented in the during my presentation. It was a good starting point. So luckily we will have a budget for a PhD student, but our operational budget still it is missing part. So we are looking for operational budget in terms of the consumables, and also build up the reactors and to try on the site. So yeah, this is what we will need in the near future.
Yes. And Gunnar, I could ask the same question to you. Where are you in terms of funding in your project?
So the project is basically funded by Central Interact project, which we started last year. And it's like 1 year to go from now. And we have very little budget for analysis and the monitoring system, because if you want to install like real-time water quality monitoring system, the cost for installing the sensors and the monitoring, the IT requirements and the data collection and the storage, that itself like cost for that. And also the hazardous substances that we are interested to look into, that is also the expensive in the analysis to do the analysis, because that is the most expensive part, I would say. And that's where we are looking for some funding to do that. Yes. Especially for real-time monitoring and the hazardous substances analysis. And the sampling is also like a challenge. When we say the stormwater, it's not like if you have a very heavy rainfall and all the water goes, then everything will be gone already. So you have to really catch the water immediately within 2 hours of the rainfall, so that whatever the substances is absorbed to the soil will be released. So we have to collect and see what is there in the water. Otherwise it will be diluted, and it's very hard for us to analyze, to find out the real pollutants and so on. So that is also one of the challenges, I would say.
Understand. Do we have questions from the audience? Yeah, sure.
Sorry.
Maybe we can give the microphone.
Yeah, I got a question for the one who had the microphone. So when you talk about phosphorus mining, so when you go to, and you seem to think what large scale would look like, kind of.
In the real application.
Yes, in the real application. But that wasn't my question. But I'm assuming that you can figure out how to do it in a real application, okay? Now, would you view that, could that be viewed as a mining operation? Or would it have to be viewed as a, clean Baltic application? Because it would come from different sources, of course. Or maybe a bit of both.
Do we have Zeynep in
microphone?
Okay, you can
Yeah,
continue.
okay. Actually, it depends how you want to see. Of course, when we are mining the phosphorus, yes, this is the point actually. We need the phosphorus, and we know where it is, and we try to find out the optimum operation to get out from this. Yes, this is a mining approach. It is not only cleaning, but of course, when we are taking out for the market-ready product, in the same times we want to clean the marine environment and that to reduce the eutrophication level. So it's like a win-win. So I think both of them, but I think the challenging part for this project is to have a market-ready product, pure, and how we can sell this phosphorus for the other industries.
Wonderful. I'm also curious, again, and this is a question for all of you, your relationships to any government body or regulators. Are there asks that you have in your work that you need change of laws or change of regulations?
Yeah, that is a tricky thing. I mean, we cultivate algae. That is the most environmental friendly thing you could do, because they are plants. They just absorb. They don't release anything like fish and mussels. But since it's not in the environmental law, there is not, algae is not there, but shellfish is there, fish and mussels. And that makes it easier for them to get a permit in order to cultivate an algae, because algae is like building a harbor or something like that. It has vattenverksamhet in the law. And that is a difficult thing. So now we got 30 hectares, and that's quite a big area. But it took us 3-4 years now to go through all the law and judges and everything that decides about it. But now we got there, and hopefully this will be a prejudicat. I don't know what that's the English word. And makes it easier for others that also would like to start.
Wonderful. And Fredrik, given that you have so many sort of practical applications to your work, do you find it easier to talk to people from outside academia about your projects?
Yes, I mean, it's a very big interest, and I mean, we do all we try to be very open. I mean, we know the trick how to cultivate and provide the biomass, and then we are very open to everyone who wants to try to do something with the biomass, because we are also in that phase that we have to build a market, a Swedish market, the algae market. I mean, algae is the most cultivated thing in the sea all over the world, and there is a lack of algae on a global scale. But in Sweden, we use it more like ingredients in food and so on, and taste enhancers, etc. But now we want to create the market to get the industry more interested in doing. And we are trying to cooperate a lot with the forest industry, because they are quite advanced in the biorefinery concept. And the researchers at KTH that we are working with, they are working with wood science, and now they are working with algae. It's chemistry in the end, but it's really nice to have their knowledge. But they haven't even seen an algae before. But now super interesting polymers. We could do something here. And this is very nice, I think. This is actually how the engineering schools could come in and actually do application that benefits for the marine environment. So that is, yeah.
Yeah, sure. I'm curious, also a question to all of you. How much do people care about the Baltic Sea when you present your projects? Is that a pressing issue, a pressing argument?
Yeah. There is a huge interest in the sea, not just Baltic Sea, all over our west coast, the Baltic Sea. People, we have a relationship to the sea. We have the archipelago, the sailing, there is many. So people are very concerned about the Baltic Sea and how to save it, so to say.
Gunnar, do you see the same thing?
Yes, yeah, there are a lot of potential interest whenever you travel to the coastal areas. You see them that, as we say, that you talk about the climate change and then you talk about the water next. So that's what is the conversation when you meet people. Yes, yeah.
We have time for a couple of more questions if we have one. Jonas first.
So I have a question for Fredrik. I have a farm in Gotland. We're trying to be completely circular, and we've looked into using slacka, the seaweed, on the farm. But at least the information my team got sort of a year or a year plus ago was that was not allowed. Has that changed?
No, it's definitely allowed. We are working a lot on Gotland, and there are 25 areas where they actively take up slack and use it on agricultural land. You have to be a little bit testing for heavy metals.
Yeah, that's what I
like.
was, the information we got. There was
but it depends on what type of slack you take up, because if it's a mixture with, I don't know if you know what zostera is, called eelgrass. It's a plant, actually land, not an algae, and they accumulate heavy metals. So when there is a lot of mix of eelgrass into the slack, you have more problems with it. We wrote a paper about it, but if you just take less eelgrass in it, it's below the thresholds that are allowed, so to say, for agricultural. And it's also when you cultivate, we have done studies, when you cultivate crops there, they don't take it up. They don't take up the heavy metals. So even if it's high content in the slack, it is not in the spinach or salad or whatever you cultivate there. So it's a lot connected in the fiber of the slack. So it's not a big problem actually.
And how far are we from being able to buy sort of the kelp or the seaweed to feed sort of an extra feed for cows and sheep, and is that something that's in production?
For the cows, it's of course very interesting because it's methane, and as I showed, there were 10 big countries there where the cows are emitting. It's like 8-10% of the total climate impact. So of course there's a big interest. And it started with a red algae from Australia and New Zealand called Asparagopsis that have a very big inhibiting possibility. But we were looking specifically for Swedish, and we also want to have something that could be cultivated, because you need to have huge. There are about 350,000 cows in Sweden. They eat 20 kilos a day of feed. And then if you add a few percentage of algae in there, you need to have a big cultivation out there to provide it. So everything you have, even if the experiments are super nice and you could show that, it's not scalable. So you have to take that into account when you go into this type of projects.
You can pass the mic to Maria. We have one final question here.
Hi, my name is Maria. It's a question to Fredrik as well. My company is constructing rain gardens out of concrete elements. And I was curious when you mentioned to mix in algaes in concrete.
Yeah.
I know. Please tell us about it.
Yeah, we have an Energimyndighets project on this. And that is to take in algae as a binding material into the concrete. And we are doing this together with rice. And you could put up to 15-20% of algae in there. And then we are going to test if the concrete lives up to the standard. And we are doing that actually in the marine environment, maybe for docks and so on. The nice thing here, if if you incorporate this into the material that will be there for 100 years or something, you will lock away the carbon dioxide for a long time, and then it will be like a sink. But if you just make food or feed, I mean, the carbon dioxide will be released immediately, so you don't have a carbon. I mean, there is other advantages it could go around, but in this case, you could store it.
Has it been any test on strength and capacity yet? For strength, for pressure on top and from the side?
No, we have just started the project, so it's just now running. Vehicle, it's called, and you could contact me, and if you're interested.
I will.
Yeah.
Wonderful. So I feel like there's so much more we can talk about, and that's in part what we're doing here is to spark the conversation.